Hello. In this video, I want to show you how to apply offset to your street network with a different offset distance. So let's imagine we have this city street network, and this is the example of Erfurt. And now with the help of extract ways with different specified features, I was able to extract um, the primary and secondary streets, then residential living streets and pedestrian streets, and service streets all separately. So I now have these three different layers of my streets, and I do it because I want to apply different offsets to them. And this can be quite tricky sometimes, but I will show you the very simple way how to do it. Yeah, so let's start. I will use the Clipper 2 library to do it. Here it is. And to download Clipper 2, you can go into the Tools, Package Manager, and as always, just type Clipper. There are two versions of Clipper, Clipper number 1 and Clipper 2. I will use the example of Clipper 2, but Clipper 1 works exactly the same. So if you're using Clipper number 1, the components you're looking for are called polyline offset. So polyline offset is Clipper component. And if you're using Clipper 2, then you're looking for Clipper 2 offset, this one, not the variable one, just just the usual offset. So probably most of you already know that the built-in offset in Grasshopper is very bad. It does not allow you to offset in both directions, so it only kind of moves the curve or offsets it to one direction. It does not create the contour around the curve from all sides, and also it is very not reliable. So sometimes you apply it to some very simple shapes and it still fails to generate anything, or it generates very buggy shapes. So I would stick to Clipper to offset, and let us just apply it to the streets L, to the first set of streets. So by default, it can be a bit buggy, but that's just because the distance is set to 0. So let me create a new slider from 0 to 10.00 and increase it just a little bit. So now you see that our lines were converted into offsets. So they're converted into contours. And as I increase my distance, you see how my lines become thicker, kind of. You also probably notice these ends of line segments. And this happens because our streets are not connected to polylines. They are all stored as line segments after this extract ways component, which is a part of Caribou plugin, by the way. So it means we need to join them first. So let me join the curves. I need to flatten C input because otherwise all segments are stored separately in individual branches and join curves cannot work with them. And so now let me try to connect the result of join curves to the offset. And here we go. So you can see that we just eliminated most of the buggy shapes. And also this Clipper offset works quite nice and quite reliable with multiple curves. So if we have intersecting curves, it will try to automatically merge all of these offsets of these multiple curves. So if I set it all the way to 10, this is how it looks like. I'm happy with the result. I will leave it as it is now. And let me duplicate these three components 3 times. So that was the first time, this is now the second time, and this is the third version of these components. And let me now connect them to streets M and streets S. Let's check what streets M network looks like. It is actually quite good. So if I only decrease the distance from my offset to something like 5 meters, so it's 5 meters in both directions, 10 together, this is what I get. And the geometry itself is quite good. So I still get these weird places, but I guess it just happens because there are a lot of smaller streets out there. We will try to fix it later. So the third network layer is the service streets, so very tiny streets. And as you can see, they are not interconnected with each other. Yeah, but we will still try to attach them to the whole street network later. So this is what we get. I will just randomly set these distances for now, and you can always check them on Google Maps somehow, or maybe you can just go to your yeah, to your site and measure with a ruler or with iPhone or whatever the distance between facades of the buildings to get down to this distance factor. So I have my three layers of street network ready to be merged, and now I only need to merge them to one shape to avoid these overlappings. I will continue to use Clipper 2 to do it because probably most of you know about this union components built in Grasshopper. So it's region union and solid union and then mesh union, but they are all very unreliable. So region union is unreliable, and also it only works with curves. And it means that if you have, let's say, some geometry like this one, when you have the outer curves and then inner curves, like these two curves, it will only take the outer curve. So it will only understand this form as the outer shape. And then BREP union and mesh union just are very not non-reliable, and they're also pretty slow. So I will continue to use Clipper 2, and it has this wonderful component called Clipper 2 Boolean, which allows me to unite multiple curves together. If you're using Clipper 1, you're looking for polyline Boolean component. It is basically the same thing. It has different sets of inputs, but it doesn't matter that much here. So let's take the outputs of Clipper offsets and connect them to the Boolean component. So the offset component has three outputs. First of them is holes, so that's the inner lines. The second is outer curves, that's the outer contours. And the third one is Clipper paths, which we don't really need here. So I do not need to distinguish between holes and outer curves anywhere here. So I will just connect them both to the same data container. So here and also here. Now, Clipper 2 Boolean only has two inputs, but it appears that if you connect these inputs like this. So yeah, first step. If you want to unite the first layer of your street network and the second one, and you connect them here, you will see what it does. So it basically takes all these places where my streets overlap, and it combines them to one shape. And this works really well. So I could not find any buggy place here. So, but we still have the third layer, and we still need to connect it somewhere. And one solution would be to apply it after the initial Boolean, like this. But it appears that you can also just connect it to the second input here. And it will still try to merge all of these data streams all together. So instead of this, and you can see how many overlapping lines we have here, we get this. So this is a much better looking network, which you can use for laser cutting, let's say, or just for visualization purposes. You can convert it to surfaces now and fill it with some hatches or maybe some colors. So that's much, much better than having this here. Now, we still get some bugs and buggy shapes. Let me try to understand why it happens. So sometimes we have um, shapes like here, right? So we have probably some secondary street or maybe pedestrian street. Then we have the living street, and then we have the service street. And after I apply all my offsets, this is what I get. So that's a bit weird shape, but actually I think I cannot do that much about it uh, now here. Because actually, like offset just did its job. It created offsets in all directions, and you can try to simplify it later, but it actually follows the streets. But in some cases, like here, we get some artifacts from our streets. So this is the result. And well, again, in this case, I am not sure we can uh, solve this problem here, just because Offset actually did a pretty nice job of creating offsets for all the streets. But maybe in cases like this one, you can see some small angles here, which do not necessarily need to be. And we can try to, yeah, to avoid those. To do it, we need to understand how join type and end type work in Clipper to offset. And I have prepared a tiny example to show how they work on this example. So let me copy the offset, create some curve input, and connect it to these two curves in my Rhino. Yes, so this is a nice example. So imagine that I want to apply offset to these two curves. And as I do it, you can see how they, as I increase my distance, you can see how these two shapes merge together. So let us check what this join type and end type actually mean. So join type, if you right click on it, can be of a type meter. It can be square. And if I change it to square, I'm not sure if you noticed, but these two angles just changed their type. So this is what happened. They were chamfered a bit at the end. It can also be a bevel, and this is what bevel looks like. So again, it tries to avoid these sharp angles, and it also can be round. So I would suggest you to avoid round shapes, just because round actually generates a lot of small points there. So it's not round, it is like a lot of smaller points. And if you explode it, I think you will be able to see it. Yes, so these are all the points created there. And we definitely do not need this complexity, so please avoid having the round set anywhere. Yeah, and then let's jump to the end type. It's another input to the Clipper to offset. End type can be of a type but or joined. And joined here means that even though our original line is not closed, it will still close it. It will still connect the first point and the last point, like this. So I would try to avoid it just because it introduces some unnecessary complexity. Square, and let us compare square and but. So as you can see, the square adds space from the end point and the last point of our curve. So square means that our whole line, including the end point, is having the constant distance to the outer shape. And also it has round, which we try to avoid, and it has the polygon. So polygon is pretty useless for us. I would say the but works the best because it does not introduce any extensions to your streets, to your curves. And the join type, which is now set to bevel, uh, like sometimes it's good to experiment with bevel, square, and meter, because square, yeah, because sometimes if you have very sharp corners, let me create an example of this, something like that. Sometimes if you simply have the meter, which is, or was it? Ah, yeah, okay. Now it actually um, creates a very nice shape here. So I wanted to show you that if you have a very sharp corner, sometimes like this angle would strike out too much. But I guess this is what the meter limit does for us here. If you set it to something larger, yeah. So meter allows you to set the threshold for um, the extension um, of this angle, and this is very helpful because, again, you want to avoid these shapes, right? So meter is set to 2 by default, and this is very good. So it already gives you nice shapes without the need to set something specifically. So you can maybe set it even to something smaller, like 1. I'm not sure it does anything. Okay, 2 is fine. So you could either leave it by meter or take the square or use the bevel. But bevel is probably, it doesn't give you that much space here. But maybe bevel is nice. So now we know how these things work. We know how they differ to each other. And we can try to go back to our main Clipper offsets and adjust some of these join types and end types to make our result look better. So let me focus on this secondary street network. I will zoom in somewhere, and I just want to try out all different possibilities. So the join type, I want to try the square, and it looks not bad, actually. I also want to set it to bevel. Again, it looks quite nice. Um, and again, back to meter. Okay, I'm not sure what I like more, so maybe something like square actually works quite nice. Um, we can maybe set square to the third layer and to the first layer as well, and check the result now. So this is what we get in the end. Yeah, which is not bad. It's quite good actually. In some places like here, you can consider, yeah, so this is what happens there. We have different types of street here, so that's why it is being offsetted to different distances. So in places like here, you can consider to turn on, to change the end type to square. So like this, and square here, so that your curves get a bit longer and the result is a bit better unification of them. But as I told you, sometimes this square results in excessive areas, like here. So I'm not sure what exactly this small line segment means here. So it can be either some access to the building, or it can be just a very small, tiny street. So you should be careful understanding what you need from your street network to be. Because yeah, sometimes you want to leave them sticking out, these smaller parts, and sometimes you want them to um, hide between the main, or at least try to hide between the main street there. Okay, I think actually that's it. So in the end, you get a nice list of polyline curves, which altogether um, constitute this street network of Erfurt in this case. And now you can do whatever you want with these curves. So you can either use the region, oh no, the boundary surface to convert them to surfaces and then do something with the surfaces. You can also just export them as curves. You can convert them to meshes and do whatever you want. You can color them. And of course, you always have to manually check your street network and adjust some places like maybe this one. Um, and yeah, but that's something you cannot avoid doing completely. Thank you and see you in the next videos.